Let's take a look at hyperbolas. This is probably the most complex of all of our conic sections that we're taking a look at. And we've got a pretty easy standard form. So let's take a look at this side first. This is going to be an x minus h squared over a squared minus y minus k squared over b squared equals 1. So a couple things on this one. Your a squared and your b squared are always going to be separated by a subtraction symbol. And your a will always, always, always be on the left, and your b will always, always be on the right. So this is different from what we were looking at with our ellipses, where your a is always the bigger number, and it goes underneath the axis where it is elongated. Okay, so these two things stay constant. What changes are these two things depending on what direction your hyperbola is going. So in this case, I have it from left to right. And if you notice, my axis of symmetry is my x-axis. And so that's why my x is leading. So take a look at where your symmetry is, and that would be what is leading. Let's go ahead and label a couple of these things. This right here is our co-vertex. This is also a co-vertex, and I'll just call it CV. We have our vertex, and our vertex here. And then we have, of course, our focus, and we have focus on this one. And our value from the center, of course, the center mark is your center, from your vertex to your center is going to be your A value, and from your co-vertex to your center is going to be your B value. And in this case, A can be smaller than B. It doesn't have to be the larger of the two values, because what you're doing is you're using those two things to create a box. And that box, if you take a look right here from corner to corner through the center, that box creates those asymptotes so that you know exactly where your hyperbolas are going. Remember that your hyperbola sits on the vertex, and then it's going to go towards your asymptotes without touching. All right, well, let's take a look at what the equation is for those asymptotes. And so if we're going to go ahead and write this out, y is going to equal plus or minus b over a times x minus h plus k. So that would be our equation that we use. So because I have plus or minus, I have two equations for each one, right? Which makes sense because I have one that's positive slope and I have another one that's negative slope. So this negative b, positive or negative b over a is going to be your slope. All right, so that's the x side. Now we have the y side. So let's take a look at where our axis of symmetry is, right? Our axis of symmetry is on my y-axis. So that means that my y value is the first one to go up. Both of them are over a squared and b squared, and they're going to equal 1. So same thing, we have our center here. I couldn't label that on the other side. We have our co-vertex on the ones that's not touching the graph. And then we have our vertex. We have our focus. Okay, this length is going to be A, and this length will be A. So the whole thing from vertex to vertex will be 2A. So if you're looking for finding that value, you can always go from your center to your vertex or from vertex to vertex and take that midpoint. Let's see here. Is there anything else that we need to label here? I think we've got it all. And then as far as my asymptotes are concerned, that's going to be plus or minus A over B, x minus h plus k. So the last part of it stays the same. My slope changes because of the nature of where things are. Okay, so that should be all of our formulas. All right, let's go ahead and look at an example here. And so if I look at this, and your Where these examples come from are linked in the description. This is from a particular teacher who does a great job doing algebraic work. Okay, so remember how we said that it all is supposed to equal 1? Something's wrong here. It doesn't equal 1. So the way to get that to be equal to 1 is going to be to divide all parties by 36. Okay, so that's a little bit of an extra complication, but it shouldn't be too bad for you. So I have x squared over 36 minus, now 9 goes into 36 4 times. So that's just going to be y squared over 4 is equal to 1. Notice that my h and my k are equal to 0. And I say that because there's nothing like in parentheses with these x and y. So that's actually going to be my center. So my center is located at 0, 0. Now it's time to find my vertices. So from 0, 0, I can figure out what a and b are, right? This is a squared, and this is b squared. So my a is going to be 6, and my b is going to be 2. So I have my center, and I know my a and b. So I'm going to go ahead and graph this a little bit here. So here's my center. And I need to find out what's leading. My x is leading. And so with my x leading, I know that the shape of my graph is going to be symmetrical around my x-axis. So my vertex are going to go left and right. So I have a is 6. I'm going to go 1, 2, 3, 4, 5, 6 to the right and 6 to the left. And so those are my vertices. Before I get too far, I'm going to go ahead and label those vertices. So I have negative 6, 0, and 6, 0. Now I've got to figure out where my co-vertices lie. I'm going to put these in blue. That is based on my b value, which is 2. So I'm going to go up 2, and I'm going to go down 2. So those are going to be 0, 2, and 0, negative 2. So 0, negative 2, and 0, 2. My foci. Oh, we didn't talk about the foci. Let's add that here. The formula for our foci is c squared is equal to a squared plus b squared. So it is straight up the Pythagorean theorem. And based on whatever we've got, we can go ahead and determine what that is. So let's figure out our foci. I'm going to change this to green. My foci. That will be a squared plus b squared equals c squared. So I have 36 plus 4 is equal to 40. So c is going to equal the square root of 40. So let's go ahead and do that real quickly on our calculators. And that's a value of about 6.32. So my foci are 6.32, and there's a couple things that we need to know about that. It's in the direction of the vertex or vertices, and it's value from the center. So when I see that 6.32, I'm going from the center. So be careful if you do the plus your focus and minus your focus. You're going to want to make sure you go from your center. So that 6.32 would go in the negative, which would be right here. So it's really, really close. Let me stick that in green. It's really, really close to my vertices. So you're not going to see much of a dramatic change there. But as far as its location, that would be negative 6.340. Right, or 32, excuse me, 32, and positive 6.320, and then my asymptotes, I need to be able to get those. All right, well, let's go ahead and graph this a little bit to see what those asymptotes look like. In fact, I'm going to use a little bit of a yellow box here. So this is going to show where my asymptotes should live. And let's see if there's a interesting color here. Let me use an orange. So if I go from, undo that. If I go from one corner through the center and through the other corner, that's roughly my asymptote. I know it's a little bit off. Right? It's kind of hard to do a straight line. And when it pops straight, we don't necessarily have it all that well. Okay. So those are my asymptotes. And so we want to go ahead and make sure that we're able to write out what those asymptotes are. So it's going to be y equals, and let's do the plus one first, and then we'll do y equals and the minus one. So b over a, so that's going to be 2 over 6 times x minus 0 squared, not squared, x minus 0 plus 0, right? And this will be x minus 0 plus 0 because that's my h and k. Well, I can reduce this. The 2, 6 reduces down to 1/3, so I have 1/3, and then that's just x. So 1/3 x is my equation that way, and negative 1/3 x is my equation that way. So I have my two asymptotes. The last thing I've got to do is go ahead and graph this puppy, and so it's sitting on my vertex, and it's heading out towards my asymptotes. So this is going to be, right, heading out that direction. So heading out towards my asymptotes. So there is the graph of this first one. All right, let's take a look at the second one. The second one I've got is, it's in the regular format that we want, and I have y leading. That means my y-axis is going to be where my line of symmetry is, which means it's going to be going up and down. All right, let's take a look at what h and k are. hk is my center, and so h is related to my x value, and k is related to my y value. So I know y is -1, which means 1 for my k. X is +4, which means minus a -4. So we have -4 there. So -4, 1 is going to be my center here. So -4, 1 is my center. And then I take a look at my vertices, which I need to grab from A and B. So A is going to be, A squared is this value, and B squared is this value. So A is going to be 5, B is going to be 3. So I am going to go, remember my vertices go up and down. So, right, with the way that this thing is going, from my center, I'm going to go up to find one vertice, and then I'm going to go down to find the next one. And it's going to be a movement of 5. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So 5 up, 5 down. And then I take a look at my B value, which is 3. I'm going to put that in blue. 1, 2, 3, and 1, 2, 3. Now let's go ahead and plot those as far as those values are concerned. So I have -4, 6, so -4, 6, and then I have -4, -4, -4, -4, and my co-vertices are -1, 1, and my other one is -1, 2, 3, 4, 5, 6, 7, -7, 1. Now, fun fact to look at here is that when you look at your vertices and your co-vertices, if you look at what's constant in each, so for example, this has a constant of -4, and this one has a constant of 1, those are going to end up being what my center is, right? Because everything is focused on that axis. So if you're given vertices and co-vertices, but you don't have your center and you don't have a graph to be able to look at, or the equation, this is one way to be able to figure it out. All right, let's figure out our focus. So that's a squared plus b squared. So we're talking about 25 plus 9. So that's going to give me 34. So my c is going to equal the square root of 34. And the square root of 34 is equal to it's equal to square root of 34, which is about equal to 5.83. So my focus is going to be about 0.83 more than my vertices, right? Because this is a 5. Let's go ahead and graph this one. So in the direction of my thing, I should have this. Okay. So that foci is going to be -4, 6.83, right? And then -4, -4.83. Okay, so it just goes 4.3 off of my vertices. All right, so now that I've got those plotted, I'm going to go ahead and do my my box here. So my box is going to look like this. So I'm just roughing this in. Okay, and then of course my asymptotes are going to come from one corner to the next. That's actually pretty good. One corner through the center to the next one. That one's a little bit off at the top, but we get the idea. And then remember that our graph is going to sit on that vertex and then come out. So it's going to sit on that vertex and approach those asymptotes. Okay, is there anything else we need? Oh, we need to know the value of those asymptotes. Let's go ahead and write that out. Remember on this one, it's going to be, we still have plus and minus, but it's going to be A over B on this one because it's leading with Y. So A over B is going to be 5/3. And we have X plus 4, so we're going to write it exactly how it says. And then plus K, and K is 1. So plus 1. And this will be minus 5/3, X plus 4, plus 1. You can go ahead and resolve that. You can distribute that 5/3 through X plus 4. And when you have the negative, it's going to end up creating a different value for you. But I am totally fine with you putting it in this construct here. All right. So now that we've done that, let's go ahead and go into, are there any more examples for us? Nope. That should be it for hyperbolas to get us started.